Welcome students. In the continuation of our previous video on basic harmonics, let us recap what we have done earlier. We have seen that harmonics are integer multiple of a fundamental frequency. Harmonics are generated when the electricity is controlled by electronics. Therefore, the electronic loads such as computers, fax machines, as we have seen, are the culprits for generation of harmonics. Coming to the same point, we'll have the study of different types of nonlinear loads. So as you can see here, welding machine is a type of nonlinear load. The other loads are given such as inverters, converters, switch mode power supply, SMPS, uninterrupted power supply, IT tools, IT industries. So all these components are connected across the web and they are the source of harmonic over a large extent. Other types are nonlinear loads comprising of iron steel industry like arc furnace, induction furnace. These are some examples. Rectifiers are some examples of nonlinear loads. DC drives, soft starters. Then all the lines, all the devices which are forming a system comprising of nonlinear loads. So various types of nonlinear loads are listed below. We again have the list of various types of nonlinear loads. Fluorescent lighting and other vapor types with electronic ballasts, switch mode power supplies, SMPS, computers, copiers, TV sets, printers, scanners, fax machines, high frequency welding machines, fans with electronic regulators, adjustable speed drives, static sleep energy recovery schemes, wind and solar generators, static war compensators, and HVDC transmission systems. So these are the nonlinear loads which are now predominant loads in today's modern power system. Coming to the next generation smart grid or microgrid, there will be additional number of nonlinear loads because the controllers basically are electronic controllers. Things such as event sequence recorders, numeric meters, numeric relays. So all these are electronic devices which may generate harmonic or inject harmonics in the system. So as we can see in this diagram that the pure sinusoidal wave is given to the system as you can see here. As a result of which there is a non-distorted wave which is a resultant wave. So resultant wave is a non-distorted wave and that is mainly because of non-linear load as you can see here. So this is one example or simple model of how harmonics are generated. Here the resistor shown is non-linear resistors, but there may be non-linear impedance and other types of loads. Now as you can see here that the current is first gets distorted as the voltage is again sinusoidal. At the source end, the sinusoidal voltage is applied, which results in formation of non-sinusoidal current. So this current is injected in the system as shown here, and it comes to the bus, consumer bus, or a bus nearer to the consumer. This is the source bus which is having pure sinusoid, but the consumer source, the current flowing to the consumer load bus forms the voltage I into Z, where Z is the impedance of bus. So this voltage is a harmonic voltage because it is based on harmonic current IH. So this gives rise to large amount of harmonic distortion since the voltage is there which is non-sinusoidal. So this voltage is applied to the other parts, other fillers or other consumers, and they get affected. They receive nonlinear voltage, they receive distorted voltage, and the problems get started at the consumers even not having nonlinear load. This phenomena has been observed in number of locations like in Vashi there is a outgoing feeder from 400 kV Kalwa substation. The feeder is 220 kV on Cornix. And now what happens that the load is non-linear and other feeders, other consumers which are connected on Cornic feeder, so they get affected and there is a sort of harmonic distortion. So this needs to be avoided because harmonic distortion is quite harmful to the system. Now let us have what is the effect of harmonics on different types of equipments. They always come in touch with other components and their effects are detrimental. So in case of capacitor, there is a burning of capacitor or overheating of capacitor because the capacitor is used for power factor improvement. It is connected in shunt with the load. So when current tries to flow through the load, the capacitor gives the low resistive path and maximum current flows through the capacitor, because of which there is a overheating and probable failure or fire results at capacitor. And this situation is not at all recommended, not desired, because this situation may lead to number of failures of capacitor banks. The other part is there may be fire hazards, there may be failure, a number of things happening. Second component is motors. Motors also fail because of overheating, increased level, increased vibration. Same thing is happening with transformer. Transformer gets overheated or increase in losses, particularly iron loss and copper loss rise. Again, there is a possibility of resonance between winding and capacitor. This resonance is a harmonic resonance because it will occur at harmonic frequencies. Reactors is also having the problem of overheating. They get overheated, then there will be fire results, and subsequently there will be failure of reactors. Then protection equipments are also affected badly, like false tripping, no tripping required, and that is mal tripping. That whenever it is not required, they will trip unnecessarily. So that is the cause of failure equipment. This can be explained with the example of Hinjwadi. As you know that in Pune, Hinjwadi is the IT park area. The Hinjwadi substation is fed from 220 kV Chinchwad substation. So there is a 220 kV Chinchwad Hinjwadi line. Now it is observed in number of cases that the line tend to trip even though there is no fault on the line. Actually, when there is a fault, like single line to ground, double line to ground, three phase fault, without any such fault, the line trips. So it is because of the nonlinear current or nonlinear load that is causing harmonic currents and that is maloperating the circuit breakers. The relays give incorrect command, false command to trip the circuit breaker, and it is observed that there is a tripping of circuit breakers without any reason. Then other is telephone. There is a lot of noise in telephone at respective places or frequencies. As you know that the telephone lines and the transmission lines go hand in hand. They are number of places. They are parallel. They are going in the same direction with a lesser clearance. So the harmonics in transmission lines are mutually inducted to the harmonics in the telephone lines, and as a result there will be lot of noise and distortion in the telephone circuits. Therefore, the transmission lines are transposed at one third distance. The phase sequence of transmission lines is reversed so that the mutual inductance is cancelled and there will not be any effect of mutual sorry inductance between telephone and transmission lines. Measuring instruments are other important devices which record measurements or which give you readings. So we calculate number of things like kWh consumption or energy audit and other parameters by taking reading through these measuring instruments. Because of harmonics, the resonance equipment gives incorrect readings and which may differ from the actual reading, and therefore they give incorrect reading or they show more or less kWh consumption. It is observed that the kWh consumption is lesser than the actual. So these maloperations are observed and they are responsible for fall in consumption. Then lines, neutral wires and cables, bus bars. So as I told you that the harmonic currents which are injected by the loads are passing through the lines, neutral wire or cables, bus bars. So there is a voltage across bus bar and that voltage is fed to other parts, other feeders, which causes very high amount of harmonic distortion. In case of neutral wires, there is a overheating of neutral wires, and particularly because of triplet harmonics, which we'll study later, there is a harmonic distortion in the neutral wire, and it is complained that neutral wire gets overheated number of times without any reason. Then electronic devices like CROs or meters or computers. So they give wrong pulses on data transmission. In the data transmission system, which is comprising of number of electronic devices such as computers, you may say, then numeric meters or servers, routers, repeaters, data concentration units. So these are all electronic devices which get wrong pulse because of harmonic pulses, harmonic problem, and they will start maloperating. Then incandescent lamps. Actually, lamps are used as economical lamps and giving higher illumination. But because of harmonic problem, there is a flicker and there is a reduced life of these lamps. And number of times it happens that there is a failure of such lamps. They will be blown off. And that final is generators. In case of generators, there is a harmonic pair of 5 inch to 7 inch, and this will start overheating of the generator without any reason, or there will be oscillations, mechanical oscillations. That is called hunting of the rotor of generator. So all these things will happen, and therefore it is felt necessary to have an equipment or a machinery to control or to mitigate these harmonics, which we will study in the later course videos. So thank you very much for watching. Have a good day.